Hi, my name is Ashutosh Sharma, and today I'll be explaining Internet and Web Homework 3. And so I will explain each question and how it runs. And also heads up for some of the questions, they're kind of long. So I also wrote some comments in the code so it would be easier for anyone to understand how the code runs in certain questions. So this is the first one, question 17.6 for chapter 7. So in chapter 17.6, it says write a script that uses looping to print the following table of values. Output the results in an HTML5 table. Use CSS to center the data in each column. So the output has to look like this. So in the code, so here header title 17.16 in the style, and you see the table. So on the table it has th and td. So the text line will be center, padding, border will be 1px. And then for the table, we have thn, and then th 10 times n, 100 times n, 1,000 times n. So you will see these on the screen of the output in the box in the top. And then in the script, you have the text.javascript, and then you have the for loop. So for far n equals 1, n is less than or equal to 6, n plus plus. So the loop will then continue, it will go until 6 is less than or equal to 6, and after that, it'll break out of the loop. Then you have the document write, and then it has the n times 10, n times 100, n times 1,000. So this will all be printed out in the table section. So when we run this code, copy path to Firefox, boom. See, so it shows here the n, 10 times n, 100 times n, 1,000 times n, and you can see each, however many times it'll show like n has 1 through 6, 10n, 10 through 60, 100 times it's 100 to 600, 1,000, you'll have 1,000 through 6,000. Okay, now we have 17.20. So for 17.20, a palindrome is a number or a text phrase that reads the same background and forward. For example, each of the following 5-digit integers is a palindrome: 1, 2, 3, 2, 1, 5, 5, 5, 5, 4, 5, 5, 5, 4, and 1, 1, 6, 1, 1. Write a script that reads in 5-digit integers and determine whether it's a palindrome. If the number is not 5 digits long, display an alert dialog indicating the problem to the user and allow users to enter a value after dismissing the alert dialog. So this is the code for 17.20. Okay, let me go up. So you have the input ID, number input, type text, you have the button. So this will check palindrome, the submit button. This will check the palindrome. The function is check palindrome, and then you have the var input. So it'll get the get element by ID, so like the number input. And then you have the if loop, if input dot value dot length does not equal 5. It'll give the alert saying the number is not 5 digits long. So if you put something in that's not 5 digits long, it'll give the alert. Then you have the return false. And then you have another for loop. So for var I equals 0, I is less than the input value dot length divided by 2, I plus plus. So going through the for loop and if statement, it'll show the alert that this number is not a palindrome. So when you put in the number, it'll identify if it's a palindrome, not a palindrome. And then it has a return false. It'll break out of the for loop. And then the next alert is that this number is a palindrome, return true. So copy path on Firefox, paste. So let's say you do like 5, 5, 5, 5. Alert, this number is not 5 digits long. So if you put another one, bam, this number is a palindrome. Now if you do it again, 2, 3, 4, 3, 4, this number is not 5 digits long. You do 2, 3, 4, 3, 2, 2, 3, 4, 3, 2. This number is a plunger. So this works. 17.22. So for this one, a company wants to transmit data over the telephone, but it's concerned that its phones may be tapped. All of its data is transmitted as 4-digit integers. It has asked you to write a script that will encrypt its data so that the data may be transmitted more securely. Your script should read a 4-digit integer entered by the user in a prompt dialog and encrypt it as follows. So replace each digit by the sum of that digit plus 7 modulus 10, then swap the first digit with the third, swap the second digit with the fourth, and output the HTML5 text that displays the encrypted integer. So let me go into the code. So 17.22. So here is the code. So the function encrypt data, var user input. So this will prompt enter a 4-digit integer. Then your var number parse user input. And then in the if statement, it'll check if the input is valid for 4-digit integer. So you see here if is an AND number slash user input length does not equal 4. So then it'll alert that's the invalid input. Please enter a valid 4-digit integer. So this will check if it's a valid 4-digit integer. Then in the next var encrypted number, so this encrypts the data. So it'll go through the for loop. For I equals 0, I is less than or equal to I is less than 4, I plus plus. Var digit, so this will parse it, and you'll have the encrypted digit. So digit plus 10 plus 7 divided by 10. Encrypted number plus equals encrypted digit. And then this will have the var encrypted number array. So here it'll switch it, so flip it. So encrypted 0 equals encrypted number array 2, and encrypted number array 2 equals temp number. And then temp number, you'll swap it, the encrypted number array to from 0 to 1, and then the same concept again. Encrypted number array 1 equals encrypted number array 3, so this will swap the numbers. Encrypted number array 3 equals temp number. Then it'll say encrypted number equals encrypted number array join, and the console log will have the encrypted number and encrypted number 3. And then this will give the alert saying this is encrypted number, and it'll catch it. So when we run it, copy path, paste, enter a 4-digit integer, so like 4321. This is an encrypted number 9810. Okay, so redo it again. So you do 4567. This is encrypted number 34112. So you see how it flips it. And it also gives you an alert saying this is an encrypted number. So this code works. Next one is 7.23. So in 7.23, you have to write a script that inputs an encrypted 4-digit integer from exercise 7.22 and decrypts it to form the original number. So, okay. So you have 7.23. So here's the function decrypt data, encrypted array. So this is the prompt. It'll say, enter the encrypted 4-digit integer in the screen. And then he goes to the try and then the if statement. So if encrypted input length does not equal 4 and is an encrypted input, so give the alert invalid input, please enter a valid 4-digit integer. So if it does not equal 4, it'll send out that alert in the main screen. Then you have the var decrypted number array, encrypted input split, var temp equals decrypted number array 0, and that'll equal the decrypted number array 2, and then the decrypted number array 2 equals temp, and then temp will, from 0, the decrypted number array go to 1, and then the decrypted number array 1 would equal the decrypted number array 3, so it'll increase, and decrypted number array 3 equals temp. And then we have the var decrypted number. So this is the for loop. So for var I equals 0, if I is less than 4, I plus plus. So it'll go into the loop until, it does not, until it reaches the requirement. So then it'll do var digit parse int for the decrypted number array I. So whatever after the loop, it'll save that number, and then the var decrypted digit will do digit plus 3 divided by 10. So decrypted number plus or equals decrypted number data. So this will give the alert. Decrypted number plus decrypted number catch error. Alert error occurred plus error. So let me run this code. Copy path. Firebox. Enter encrypted 4-digit integer. Decrypted number 9078. So let's say put 123. Invalid, and please enter valid 4-digit integer, encrypted integer. So you see, if you don't meet that requirement, it'll inform you that it's an invalid. So if you do, 1234, encrypted number is 6745. So it'll accept it because it's reached that requirement. So this was question for 7.23. Now we go to 8.9. So we'll go to chapter 8 now. So for 8.9, one interesting application of computers is drawing graphs and bar charts, sometimes called histograms, right? A script that reads 5 numbers between 1 and 30. For each number read, output HTML5 text that displays a line containing the same number of adjacent asterisks. For example, if your program reads the number 7, it should output HTML5 text that displays, the stars 1, 2, 3, 4, 5, 6, 7. So this is the code for 8.9. So here you have the script, the for loops of var I equals 0, I is less than 5, I plus plus. So it'll go into the loop until, I think after it hits 5 less than 5, so it'll stop, so it'll take 4. So the var input prompt, it says enter number between 1 and 30, var number parse input. So if number is greater than or equal to 1 and number is less than or equal to 30, so it'll be in between that range. And then you have the asterisk, repeated number, you have the enter HTML, the asterisk. So it'll break the loop, and then it'll alert saying please enter valid number between 1 and 30. So between those numbers, if number is less than or equal to 1, greater than equal to 1, sorry, and less than or equal to 30, that's where the number that you'll have to put in for it to be valid. So when we run this, copy path, enter between 1 and 30, 4. So that was one time. 5, second time. 6, the third time. 7th, fourth time. 8 is the 5th time. Boom. So you see how it writes them all in asterisks in order. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, and then you have 1, 2, 3, 4, 5, 6, 7, 8. That's the code for 8.9. Now we move on to 8.11. So 8.11. So a mail order house sells 5 different products whose retail prices are as follows. Product 1, $2.98, product 2, $4.50, product 3, $9.98, product 4, $4.49, product 5, $6.87. Write a script that reads a series of pairs of numbers as follows: the product number and the quantity sold for 1 day. So here's the code. So here the script. So here in the constant product prices, this defines the product prices from 1 through 5, $2.98, $4.50, $9.98, $4.49, $6.87. And then here in the function to calculate total, so this will calculate the total value of some, and the continue loop it's true, the while condition, so let product number equals parse end, enter product number 1 through 5 and quantity sold for next product, or any invalid input to exit. So here it checks for the if product number and product prices is then product number, the continue loop equals false break. So this will check for the exit condition. If it's met, then the quantity equals parse prompt, enter quantity sold, and this will validate the quantity. If it meets that requirement, it's NAND quantity less than or equal to 0. So it'll give you alert if valid quantity, please enter valid quantity. So this will validate if what we've put is right or wrong. And then the sum plus or equals product prices with inside the bracket product number times quantity. So this will calculate the subtotal and add to the total. And then the alert total value is dollars plus sum to fix 2. So this will display the total value. And then calculate total will call the function to start the calculations. So when we run this, copy path, enter product number 5, so 4. 4, and then enter quantity sold. So quantity, so let's say we put 449. Enter product number or any invalid input to exit, so enter quantity number for product. So 4, enter quantity sold 2, enter product number 5, 5, 2, 1, entering product number 1 through 5, 1, 1, enter product number is like 4. Enter any invalids, let's put 6. So you see, so the total value is $77.48. So calculate it. So all the numbers that we put in as the total value is $77.48. This was for 8.11. Now we go to chapter 9. So go to chapter 9. So 9.19. An integer is said to be prime if it's greater than 1 and divisible only by 1. Itself, for example, 2, 3, 5, and 7 are prime, but 4, 6, 8 are not. So for A, write a function that determines whether a number is prime. B then uses function a script that determines and prints all the prime numbers between 1 and 1,000, and how many of these 1,000 numbers do you really have to test before being sure that you found all the primes. Display the result in a text area. Initially, you might think that n-2 is the upper limit for which you must test to see whether a number is prime, but you need to go only as high as the square root of it. Well, rewrite the program using the square root method to calculate the square root and run it both ways to estimate the performance improvement. So when we run this, so I'll explain my code. So text area, ID result, rows 10, columns 50. So this will be the output, how big it is initially. So, and then the function is prime. So it has the conditions if num is less than or equal to 1, return false. If num is equal to 2, return true. If num divided by 2 equals 0, return false. You go to the for loop for let I equals 3, I is less than or equal to the math square root num, I plus or equal to. If num parentheses I is 0, percentage return false, then it'll return true. And then the function will say find the prime number. So let primes for let I equal to I is less than or equal to 100, I plus plus. If its prime is I, prime I pushes I. So this will go through the loop until it's met its condition, and then it returns the primes. So it'll go through the loop until the condition's met, which is quite a lot. Then let the prime numbers equal the find primes, and then the result text area will show the results and the prime numbers. So when we run this, copy path, paste. So here's the prime numbers initially, but you can drag it out. So this shows you, I mean, most of it. I mean, the screen is not big enough, but it shows we expanded out the prime numbers, 1 through almost 1,000. So this is the code. Now we go to 19.22. So computers are playing an increasing role in education. Write a program that will help an elementary school student learn multiplication. Use the math.random to produce two positive one-digit integers. It should then display a question such as how much is 6 times 7? Okay, what did I do here? Yep. All right, so this is the code for 9.22. So this is the font. So this is text line, background color, the margins, container, how wide, the width of it, background color, radius, the color of the box shadow, header one. So this it shows the colors, padding, width, font size. Same goes for the button as well. And button hover background color is light sky blue. And here in the body, you have the class, the container, title of the multiplication quiz, and get the input type, product, placeholder, your answer. This will be in the output button click, so this will check the answer, and I'll show the results. So the script, you have var number 1, var number 2, and then the functions generate question. So this will ensure that, like, numbers 1 is not 0, and also going forward for number 2 as well. And then you have the function check answer, var user answer, use parse int to get the element ID, so the product value. And then it has the if statement, if user answer equals number 1 times number 2, then it'll show the product and it'll also print out the results. Else, document get result in HTML, font color no, please try again. So it'll give the option. So if it runs, if it meets the condition, it'll say very good. If it doesn't, it'll say no, please try again. And then the generate question, it generates the first question after you've completed it, when you reset it. So when we run this, copy path. So multiplication, how much is 9 times 6? 54. Very good. What is 5 times 2? 10. Very good. How much is 9 times 40? What is 9 times 5? It's 45, but let's say we put 34 as a mistake. No, please try again. Check again. 34. Please try again. 33. Please try again. 23. Please try again. 45. Very good. It's 45. Check. It's 45 times 2 is 10. Very good. 8 times 7, 43. No, please try again. If you do 12, 21, no, please try again. It's 56. Very good. This 1 times 6, 6. Very good. So when you get it right, it's very good. If there's a mistake, it'll say, no, please try again. So this was question 9.22. So now we will go to 9.23. So 9.23. The user of the computers in the education is referred to as computer assigned instruction, CAI. One problem that develops in the CI environment is student fatigue. This problem can be eliminated by varying the computer dialog to hold the student's attention. Modify the program in exercise 9.22 to print one of the variety of comments for each correct answer and each incorrect answer. The set of responses for correct answers as follows. Very good, excellent, nice work, keep up the good work. Set of responses for incorrect answers as follows. No, please try again. Wrong, try once more. Don't give up. And nope, keep trying. So here in the code, this is the body. So just the font style, container, background color, each one as well, the colors, input, the width, how long it's going to be, the font size, the margin, the button as well, the background color, The border, margin top, the font size, button hover's background color is going to be blue. Division class, so this will have the container, the header, so this will the output, the main screen multiplication quiz, it'll show the question, the ID product, your answer, the button click, this will check the answer, and the results. And the script, you have var number one, var number two. So same rules applying the function. So this will ensure that number one is not zero, and same goes for number two as well. And it'll go through the questions, enter each show how much is lead plus number one, and the function get response is correct. So if it meets the conditions, it'll write it's very good, excellent, nice work, keep the good work. If not, it'll say no, please try again, wrong, try once more, don't give up, we'll keep trying. So the var index, so mat.random times the response length, and the function will check the answers to see, if it's correct, if the user's answer equals number one times number two. So the get response will check it's correct. It's correct, show up the options. And then the generate question will generate the first question. So when you run this, copy path, multiplication quiz, 9 times 2, 18. Keep up the good work. 9 times 5, 45. 9 times 2, 18. 6 times 1, 6. Keep up the good work. 4 times 1, 2. Don't give up. Do it again. No, please try again. Don't give up. It's 4 times 1. Don't give up. Wrong. Try once more. It goes through all those options. So 1, 4 times 1, 4. Very good. 8 times 2, 16. Very good. 9 times 3, 27. Excellent. 9 times 3, 9 times 3 is 27. Excellent. Nice work. So you see it goes through all the prompts. So for right or wrong. So this was for 9.23. Now we go to 9.24. So that's 9.24. A more sophisticated computer assisted instruction system monitor the student's performance over a period of time. Decision to begin a new topic. It's often based on the student's successes with previous topics. Modify the program in exercise 9.23 to count the number of correct and incorrect responses typed by the student. After the student answers 10 questions, your program should calculate the percentage of correct responses. If the percentage is lower than 75%, display, please ask your instructor for extra help, and reset the quiz so another student can try it. So 9.24, this is the code. So here it's the same thing, the body, it shows the font, the text line, background color, the margins, the content center, the align center, the height. Same with the container, how tall, the width of it, the background, border, box, the color of it. Each one header, the color is going to be light salmon, input, padding of it, how big it's going to be, the width, the size, the margin. Same goes for the button as well. And we also have for the background color royal brew as well. So here we have the H1 multiplication quiz, division, ID question, input type text, ID equals product, placeholder your answer, button click and check answer, check the button as well. And the script, you have var number one, var number two, var correct count equals 0, the function generate question. So number one times 1 plus 1 that ensures the number 1 is not 0, times 10 as well for the number 2. Document international, how much is b, number plus 1. So this goes through all the options again, times b, the number 2, and then the function responds if it's correct. Very good, excellent, keep up the nice work. No, please try again. So this is the same continuation, 9.23 as well. And then that's the function, check answer to see if it's right or wrong. But then what's more important is the if statement here. So if total count equals 10, it'll verify the percentage. by correct count divided by total count by 100. If the percentage is less than 75, then it will result that, that please ask your instructor for extra help, exit the condition, and if it's correct, doc can get the product value. And the function result, correct count equals 0, total count equals 0. This will generate the first question. Path. So how much is 9 times 6? 4. 3 times 3 is 9. 9 times 5 is 45. 4 times 4 is 16. 2 times 2 is 4. 6 times 0 is 0. 2 times 0 is 0. 9 times 7 is 63. 6 times 1 is 6. 5 times 1 is 5. Congratulations, you passed the quiz. Let's say you do 3 times 2 is 4. That's wrong. 3 times 2 is 2. That's wrong. 3 times 1 is 3. That's wrong. 3 times 2 is 4. That's wrong. 3 times 2 is 7. That's wrong. So go through all the command. 3 times 2 is 9. That's wrong. 3 times 2 is 8. That's wrong. 3 times 2 is 10. That's wrong. 3 times 2 is 11. That's wrong. 3 times 12 is wrong. 3 times 12 is 13. That's wrong. 3 times 14. Wrong. 3 times 2 is 15. That's wrong. 3 times 16. Please check again. Don't give up. Keep trying. It's 12. Please try. Give up. Please try again. Wrong. Try once more. Don't give up. So run this. So 6. Keep trying. So when you click through it 10 times, you see it in the option to actually please see your instructor for extra help after 10 times and recommend it. So if you do it one more time, see, so after 10 times, so I wrote, if you do it 7 times 1, 10 times, I wrote 611. Now it has recommended, you ask your instructor for extra help. So 9.27, project exercise 9.22 to 9.24, develop a computer-assisted instruction program to teach elementary school student multiplication. This exercise suggests enhancement to that program. A, modify the program to allow the user to enter a grade level capability. At grade level of 1 mean use only single-digit numbers in the problem. Grade level 2 means to use numbers as large as 2 digits, and so on. B, modify the program to allow the user to pick the type of arithmetic problems he or she wishes to study. Option of 1 means addition problems, only 2 means subtraction, problem only 3 means multiplication, problem only 4 means division, 5 means intermix random problems of all these types. So this is my code for 9.27. Same body container, so this is all same, just going through it all. Here you have the label for grade level capability. So this will show the options in the main screen if you want to use single digit numbers, 2-digit numbers, or 3-digit numbers, and also the addition, subtraction, the option values for the type of arithmetic problem. So in the output, it'll give the option if you want to do the addition or subtraction, multiplication, division, or random. And this will check, the results of it. And then you have the var count, so the parsing it, and then var max number. If 1 is to 9, grade equals 2. So this will all check if it reads that command. So this will the switch breaks as well. Doc can get element type. What is B? num2 break, inner HTML. So this will all go through the switch statements until it breaks. And then the function is correct, you'll get a very good, so it's everything, you get a very good response, excellent work, keep up the good work. No, please try again if you get those statements wrong. Basically, it's just everything combining into one. So the responses will total count, the percentage as well. Please enter instructor for extra help. So it's basically everything. So basically, it's all three questions into one, and with the options if you wanted to go the addition route, the subtraction route, the multiplication, division route. So as you'll see in the code, paste. There you go. So grade level, capacity, single digit numbers, addition. So what is 3 plus 8? 11. Excellent. What is 6 plus 8? Let's say for 1. No, please try again. So that's wrong. Let's see, you want to do subtraction. What is 4 minus 3? Obviously, that's 1. Very good. What is 3 minus 1? 1. No, keep trying. Multiplication. What is 2 times 4? That's 8. What is 6 times 7? 3. That is wrong. Division. What is 5 divided by 8? So take a calculator for that. So 5 divided by 8. 0.625. Keep up the good work. What is 9 divided by 2? Let's put 2. That is wrong. So when you go through all the options, gives you all the, so like what is 63? 12 divided by 63. Put 2. Please try again. Please ask your instructor for extra help. So when you go through all of this, it's basically everything now with you having the option if you want to do two-digit numbers or you want to do the addition, subtraction, multiplication. So that was for 9.27. So now we will be going to question chapter 10 now. Chapter 10, raise. I had a script that simulates the rolling of two dices. The script should use math.random to roll the first die. And again, to roll the second die, the sum of the two values should then be calculated. Note since each die can be shown an integer value from 1 to 6, the sum of values will vary from 2 to 12. 7 being the most frequent sum and 2 and 12 the least frequent sums. Figure 10.22 shows the 36 possible combinations of the two dice. Your program should roll the dice 3,600 times. Use a one-dimensional array to tally the number of times each possible sum appears. Display the results in each supply table and also determine the totals are reasonable. There are 6 ways to roll 7, so approximately 1 of 6 of rolls should be 7. So this is the code. This is the header, border type, background color, the main screen. The header will have the sum, the frequency, expected frequency. The body will have the result tables, frequency of new arrays. There'll be 13 tables, 13 arrays, and then the for loop. This will simulate the rolling dice 36,000 times. So for var I equals 0 high is less than 36,000. So this is going to do it on 36,000 times. And then for this for loop, the var j equals 2j is less than or equal to 12. This will display the results in the table for the rows, the cell, the frequency, and the expected frequency. And then the sum cell dot text content, frequency cell dot text content equals frequency, and the expected frequency will equal the total rolls divided by the number of possible outcomes. So row appended child, frequency cell, the expected frequency cell, and row. So when we run this, copy path. So here, this shows the sum, the frequencies, rolling dice simulation, the expected frequencies for each. So 2, frequency 0.05, expected 1,000, 3, 0.926, expected frequencies 1,000. So this is the rolling dice simulation. 7.14. Now the last one, 10.17, the final one. Simulation, the torso and the hair. In this problem, you'll recreate one of the truly great moments in history, namely the classic race of the torso and the hair. You will use random number generation to develop a simulation of these memorable events. Our contenders begin in the race at square one of 70 squared. Each square represents a possible position along the race course. The finish line is at square 70. The first contender to reach or pass square 70 is rewarded with a pail of fresh carrots and lettuce. The course weaves its way up the side of a slippery mountain, so occasionally the contenders lose ground. There's a clock that ticks once per second. With each tick of the clock, your script should adjust the position of the animals according to the rules. Figure 10.24, so the animal move type, percentage of time, the actual move of the torso. And then this is part one of it, and part two is the hair. And then it says use variables to keep track of the position of the animals. Position numbers 1 through 70. Start each animal at the position. Starting gate of animal slips left for square. Move animals back to square one. Generate the percentage in 10.24 by producing a random integer in the range. For example, torso performing a fast plod. And then here it says begin the race by printing bang and they're on. And for the click, it will say all print positions other than T, the H, or the ouch. In case of a tie, it should be blank. So when we run this, well, I'll explain the code for 10.17. So this is the table, the same concepts, of how the background's going to be. In the header, you have the torso and the hair. So this will be the header table, TH second, torso position, header hair position, body, the race results, torso positions 1, hair positions 1, seconds are 0. And then the function move torso, var move type equals math.floor by math.random times 10. So if move type is less than 5, torso position is plus equals 30. So this is the fast plod, torso position. This is the slip if it slips. And this is the slow pod, torso position, else plus or equals 1. This will go through all the commands, function, move array. So hair position, sleep, so there's no move at all if it's less than 2. If move type is less than 4, hair position plus equals 9, so that's a big hop. If else if that's hair's position is negative 12, that's a big slip. And if move type is less than 9. And then the hair position plus or equals 1 is a small hop, so it'll show each hop and how it will work. Hair position negative 2, that's a small slip. Function run race, so the race results. So the alert in the beginning will be bang, and they're off. So torso is less than 70, here is less than 70, torso. So this will go all through the commands, and then it'll give the winner results if it's torso or hair, and then the alert will be the winner is one of those two, torso or hair. So copy path. So here, torso and the hair. So this is the beginning prompt. So here, bang, and they're off. So now, okay, ouch. So this is showing the command. Ouch. The winner is hair. So here, so it explains it. And so I'll show it. So bang, and they're off. Ouch. So it shows that there's a hop somewhere. Ouch. So again, they have the torso position, hair position. Probably they have met somewhere. Ouch. Ouch. So they've connected or they've met again. Ouch. The winner is hair. So it's so probably those ouches when they probably equal the tour position, hair positions several times. After that, it concluded that the winner is hair. So this is the codes for homework 3, and I hope they were very helpful. Thank you so much. Really appreciate it. Thank you. Have a good night. Bye.